Sahar. Hi, Sahar, how are you?
Thank you. Fine. How are you?
I'm good too. Thank you so much for asking, and thank you so much for joining us. It's really an honor for us to have you here.
Thank you. Same here. Should we wait until 12:45 or can I start?
No, 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 you can start your presentation.
All right. Let me just share my screen. So let me know if you can see my screen.
Yes, I can perfectly say it. Good luck. Stage is all yours now.
Thank you. Very welcome to this presentation. Thank you very much for the introduction. So my name is Sahar Tahvili, and today I'm going to talk about predicting the future of data science and machine learning. I divided this talk in two main parts. First, let's review together what we achieved from the beginning, where we are, and what challenges we are facing right now in artificial intelligence. Then maybe having this information can help us to predict the future in a more accurate way. Uh, I got already introduction, thank you. But more information about me, I have background in applied mathematics, bachelor and master, and then I got my PhD in software engineering with a focus of software testing and employing AI technologies algorithms for improving the testing processes. Previously, I worked as a senior researcher at RISE Research Institute of Sweden. Then I joined Ericsson as senior data scientist, and now I'm working as operational team leader at Cloud RAN integration and test at Ericsson here in Stockholm. I'm chairing and co-chairing some workshops and conferences, mostly related to AI and testing, which is my domain. And until now, I published two books. One is my PhD thesis, and the second one, which will be hopefully published in August this year, is Artificial Intelligence Methods for Optimizing of the Software Testing Processes, with a practical example and exercises. So this book is more focusing on the industrial aspect of AI and software testing, and also is useful for students at universities as well. Some results that we gathered in this book I will present in this presentation. But let's review together from which point we start the Industrial Revolution. Actually, it was in 17th that we have Industrial Revolution steam-based machines, that it was the first step of changing our lives that time. And it was very successful and changed a lot of things. But the first Industrial Revolution, with all benefits and impacts, still has less impact compared to the second Industrial Revolution. And also all other Industrial Revolution has less impact compared to the second due to the electrification, steam-based machines, and also mass production, electrical-based machine and mass production. The change that we started that time, it impacts a lot the things that at the time, and now the things that we are doing today actually comes from that point. Later, we went to the Industrial Revolution. Computer-based, internet-based knowledge and machines went from the mechanical machines, we shift to digital machines. And it was maybe the story, the first information revolution of the story of AI and machine learning. But today, combining whatever we did in the previous with now, we are facing fourth industrial revolution or second information revolution, which is artificial intelligence. So it took a lot of time that we reached this point, and we are not even in the maybe optimal point of artificial intelligence. And I'm going to explain my views on why we are not reaching that point yet and what is the barrier. We all know what is the advantage of using artificial intelligence, so we don't need to repeat it. But some bullet points, some points that maybe we can focus on, is the market that will grow from 8.43 in 2019 to 117 billion by end of 2027. That is the prediction that Gartner has, and a lot of research institutes, they have this prediction. But we should consider, is it doable, or still we are facing some barriers? And if so, what is the barriers? How we can overcome the barriers? How we can reach this point? Or reaching this point is good enough for our daily life, for our products, for our future, for our technology? Until now, some benefits of AI that everyone agreed about that is first reducing the human errors, especially in the safety critical systems. So I said I have background in software testing. Using artificial intelligence for testing safety critical systems like train or airplanes can help us to save a lot of lives actually. So that is the biggest impact, that we have minimum, at least we are trying to have the minimum human errors by replacing some of the work by machine learning and artificial intelligence. And of course, some risk that we as a human can face by doing some jobs like installing an antenna or, working as a policeman or other stuff in the dangerous situation can be replaced by robots today. So there is no discussion about that, and everyone, it seems, are happy with that. Also, some repetitive jobs can be reduced by using artificial intelligence. For instance, data collection up to 55% can be reduced, is almost half of them, by using machine learning and artificial intelligence. And same for approval, more or less, and for updates. But one of the big advantage of artificial intelligence is decision making, faster decision, intelligent decision in the real world and also in the VUCA world. VUCA world is a situation that we have uncertainty, ambiguity, complexity, and we need to make a decision very fast. We are, as a human, we are lacking knowledge, we are lacking mastering the situation, remembering the history. And in the stressful situation, as a human, we are not maybe enough good enough to make a correct decision. In my opinion, one of the big impact and usage of artificial intelligence is in that board, in the VUCA board. And also we can get support 24 hours in every day, which is still not doable by human, or it takes a lot of, time and cost for us. If you just let me go over a pointer. If you check this figure, which shows how in the VUCA world, how artificial intelligence can make a decision, the big differences with the human decision is the data gathering. When an algorithm, AI algorithm, can gather data from different sources from entire world, which is not doable by human, and also continuous learning process, and this loop which is connected to each other, and planning and replanning and making a decision and defining, generating different plans based on history and based on several situations. So in that sense, using artificial intelligence shows a lot of potential. But coming back again to today, where we are. So again, in my domain, I try to summarize some of the research has been done in the domain by Gartner and also World Quality Report regarding the involvement of artificial intelligence in the software development life cycle, which is high-tech technology. We are using it everywhere is needed in all countries. And in this figure, you can see how AI is involved, how much AI is involved in the software development life cycle compared to human. It still is not even 50%. And by this mission that we have, that we are gonna to have more and more AI, still we are lacking of AI involvement in that domain. But why? But in some places, in some steps, some phases of software development life cycle, we have more involvement of AI, as you can see in the test development or execution analysis. But in some parts, like requirement analysis, test planning, even in optimization, we see less involvement of AI. And it's just because of the nature of the data, of the input. In the requirement analysis, with the close, interaction with the customers, still in the software development life cycle, we are using requirement specification written by human, analyzing different standards, changing a lot of things based on the customer needs. There we can see less involvement of AI. So the input in this phase is natural text, and it still is hard for algorithm, even using different new technology in natural language processing, is still hard for the algorithm to understand and realize and acting better than human. But in some places, like test development and execution analysis, why we see more involvement due to the nature of the data again here. Test automation is a hot topic. It's demanded. All companies want to have test automation. They want to go from manual testing to semi or fully automated testing, and they put more effort. Although the nature of the data here might be test specification, might be text, but sometimes we have some codes and we can train the model based on that. And due to the demand, due to the time saving and money saving that we can do by test automation, and sometimes finding more bugs and error or faster, companies effort a lot for these steps. That's why we can see in the test development, we have more involvement of artificial intelligence. Also in execution analysis, when the input is log files, after each test execution, we have a large set of log files. Maybe for one test case, we can have several files, but the logs are machine generated, which means it's easier for a machine, for machine learning and AI models to read the data, to analyze the data and make a decision for the next execution. So nature of the data, the time that companies, the goal and policies of companies play a lot. They are game changer in this domain. That's the conclusion of the today involvement of AI on the software development life cycle. But what challenges we are facing beside of the nature of the data gathering is not limited just to data. Actually, again, in the book, we try to summarize, categorize the challenges of artificial intelligence into four different groups. For instance, architect. It can be a poor architect choice or wrong architect choice, AI strategies, cybersecurity risks. Still, especially for using the cloud system, we are facing some cybersecurity risk. Then some of the companies, they are not very happy to share the data in the cloud system, and until we can solve this problem very well. Supporting IT system and again in integration with the cloud. So if we are not having a good architect of AI, it doesn't matter if we are a big company or a small medium company, still we are not able to use it, and it cause can impact directly the cost and effort that we are putting on artificial intelligence, where it could be solved easily if we know in which phase we are facing the problem. Data, as usual, always is a problem. The data by itself, the quality of the data gathering, the size of the data still is a problem, especially for small companies. The number of generated and gathered data is not good enough to train AI model. But there is a solution for this part as well. I mean, sharing the data in the cloud system and using data as a service, I will cover it later, can help small companies to cover that part. The next problem is the complexity of artificial intelligence. It could be complexity in the model, lack of skilled workers, operational complexity, meta learning, and high computing power infrastructure. For using AI, you need to have a good infrastructure. You need to have data scientists, you need to have data engineers, and still with having such a team, AI is complex. And if we are not solving the complexity of the AI, still we can't use it even in the big companies. And last but not least is cost, ongoing fees. AI is expensive, infrastructure is expensive, skilled workers are expensive, maintenance cost is expensive. And when, as a small company, sometimes when you need to buy the data or you need to use a consultant for solving your AI, the value of return on investment might be negative from the beginning. Maybe it takes time, 2-3 years to achieve a positive value of return on investment. And it's very critical situation for making a decision to jumping from a manual work that we are doing today to be more active and involving more artificial intelligence. But we try to find a solution for each of them, and is ongoing, and is that's why the predicting, I mean, the future of AI, in my opinion, it should focus more on two things. First, automated machine learning, AutoML models. It helps a lot that we can jump some of the steps. In the next slide, I'm going to show you how for running and using AI model. If we can use any automated model, there are some free models that we can use, then we can skip some steps. We can skip having super skilled workers. The things that we need is the data, high quality data, which needs to be injected to the model, and then in the output will be prediction, classification, clustering, whatever is the goal. Then in this sense, you can assume AI as a black box or gray box, that you are not caring about the process. The process that we try to summarize here from the beginning. Although we try to match these steps with the new technology, but that is the happened in the high-tech companies, and still a lot of improvement is needed. From the beginning, the first step for running an AI model is to check the data availability. If the data is available, then a normal way of doing data analysis, data cleaning, feature extraction, transformation, normalization, visualization can happen. But if what else if the data is not available, if I'm a small company and I don't have the data? First, it doesn't mean that I captured the required data correctly. Sometimes the companies need to learn how they can capture the data, what means data for them. Sometimes they are thinking the data is just sort of log files or some machine generated data. No one can, sometimes they are not thinking that even Excel file can be considered as a data. It's just be to transform to the data shape and can be used for machine learning. Sometimes they can buy data from other companies. It depends on the, of course, the policy and the goal of the data, running a data model, but is doable buying the data. Then again, we face this step that we have the data, our own data, or we buy data, or we capture the data somehow. But very important things in machine learning is to check the accuracy of the model. The things that we are doing is correct, good enough or not. For that, we need something which calls ground truth. And sometimes this ground truth does not exist and is very hard to check against the reality, the performance of the model. For instance, the prediction. Sometimes we have it, for instance, in the weather classification, we can check the performance of the model with the reality, but in some cases we don't have such a ground truth. But how we can do, there is again other solutions. For instance, using unsupervised learning, when you don't need to label the data, and you can then you need to trust the model until that point that you find a label data, and you can use semi or fully supervised learning approaches. And sometimes generating the ground truth is challenging, but is still doable. Human work. Very much we are involved, at least in the testing domain, by human labeling. Of course, it's time consuming. Of course, it suffers from human work, uncertainty, ambiguity. Again, what is the only solution? We should involve people, human, in our domain, testers, integrators, more with AI. We should merge together. They have a lot of experiences by subsetting of the data, sharing a subset of data. Manual labeling can help us to train the model and modify the performance of the model together. We don't need to skip the human completely. We can involve them. So it's one way that we are very involved. Sometimes we can extract the ground truth from the system. Machine generated data labeling. In the book, we explained a lot how each step can be performed, but it's a summary of the things that we think that we can do. Another important aspect in the machine learning is tuning the model for optimizing the performance. And that part, even we can go for our machine learning model, we can go for our manual tuning, or we can use these AutoML approaches, which is very popular, and we skip entire process until deployment. if we have such a good, AutoML model, in fact, the only things that we need to concern is data availability. One or two, the data is available or not. We solve the problem, we inject the data to the AutoML, and we see just the results. So entire this flow chart can be considered as a black box. You don't need to take care about a step by a step and having people and involving people more or less, and is a solution, which is one of the direction of the future development of machine learning. Otherwise, if we go with such a complex system, which requires a lot of effort, we are not sure if we can reach that point that we are expecting right now. Another good strategy as a future of AI might be is data as a service, DAS, which is very related and very connected to the cloud computing and cloud system. You can call it as a data management strategy that can be used for storing the data, for analyzing data, for sharing data. Then this part, if you have no data available, can be covered by DAS. You can borrow the data, you can buy the data, you can train your data on the other companies, other servers, and you skip a lot of hardware work, power, computational power, local storage. All of them can be skipped by using DAS, data as a service. DAS is already started, and there is a lot of, application for it, but still a lot of improvement needs to be done to use it as a real application, as a real platform. But benefit of DAS, one example, again, weather prediction. So weather prediction, the data for weather is everywhere is available for all of us. So we can use different platforms to check the weather. But how we use this data, from a simple choice to choose your clothes today, washing your car, until critical situation, like how you should be ready for a flood. All of these three are application from very simple until critical and complex situation by just weather information, which is available for everyone. Now assume this scenario that these data, all kind of the data as a DAS, can be available for human, for researchers, for vendors, for companies, and how much we can gain by using DAS. We are not ignoring that there is a lot of risks still, like cybersecurity risk, other risk, but the benefit that we can get, first innovation and applications that we have of DAS, is much more bigger compared to the limitation and risks that we have from DAS. So that's, in my opinion, is another direction of AI in the future that we should be more involved and more invest on that in order to reach the point that we are expecting in the AI as a fourth industrial revolution. So that's all for me. So let me know if you have any questions.